purposes. All right, I'm broadcasting on YouTube. Let's make sure that's happening. Check, check, check. Okay, looks like I'm broadcasting live on YouTube. Although if you're in Discord, you don't really need to worry too much about it. And what I'm going to do is I'm going to share my screen now through Discord so that we can see what's going on. All right, boom. All right, you should see my mug and you should see my desktop background, which is a picture of the Apple, standard Apple background. All right, let's run through our checklist just to see get as far as we can. Activate VPN. So you don't need that because that's required for audio. So I'm going to disconnect my VPN. Find a quiet location. That's still helpful. Tell your roommates you're in class so that they can shut down their Iditarod training. Turn off your notifications on your phone and computer. That's still helpful to make sure you're not getting constant notifications while your class is going on. So I just did that on my devices. Put on headphones so you don't get echo. Turn down any extra apps or browser tabs so that we don't encounter any demands on our CPU. Okay, let's see. Let me make sure I've got nothing else extra here. All right, I can shut down my music. Great. And let's see what else we got. Open Canvas. All right, I got that going. Let's bring that down for us. All right, Canvas is broadcasting. Open Eclipse, connect to Saros. So I've got Eclipse running and I've got Saros up. So go ahead and get that started if you haven't already begun that. We don't need to open Firestorm. We don't need to do our avatar. We don't need our environment set up. We don't need our draw distance. Classroom is Discord. If you know that there's someone that isn't here, please reach out to them in class. In Discord, if you hear background noise from someone, you can manually mute them. I'm not sure. So like I muted a few people because I was just getting some background noise. I'm not sure if that's, oh, that was just me. So let me server mute you. All right. So if you're server muted, you're just getting some background noise. That's all. All right. All right. And I am also monitoring Slack. So if you need to if you want to communicate via text messaging, you can communicate on Slack and I will see that. Let me make sure that's up and available. Great. I'm watching the class channel. Okay, and then we have to deal with our attendance machine. So I don't have the attendance machine running because we're not in game. So I'm just going to just do a rundown of our presence today. Today's class 27. Okay, looking down at our calendar, we are on March 22nd. It is class 27. We're going to be reviewing a little bit more about chapter 16 today, hopefully looking at an implementation of linked lists and also looking at a comparison between linked list and array list running time. So let's run down and do a attendance. And what I'll do is I'm going to open this up. I'm just going to directly take grades. That'll save me some time. All right, I'm going to unserver mute folks so that everyone can come on and say here when I call your name. And that will be great. And everyone will be wonderful and we will be happy. I'm looking up the assignment for attendance for today. I'm scrolling through my windows. There's my window. All right, and let me order it alphabetically. And just because poor people at the end of the alphabet never get to go first, we'll do it reverse alphabetically. All right, so calling off names, if you could unmute and just say here and maybe your name, just so I can understand who's responding. Let's start with Ethan, Vaughn, Faith, and Adeline. Good morning. Morning, Faith. Morning, Adeline. Great. All right, let's see. We've got Frank, Luke, and Sam. Good morning. Monty, sorry. Yep. And let's see, Sam. Sam, I see you. I don't hear you though. See that you've muted, but I still don't hear you. Give you a second to work that out and then pipe up when you get it. All right, next three, Thomas Matson, Morgan, and Matthew. Morning, Morgan. Morning, Matthew. And Thomas, I also see you, and I see that you're unmuted, but I don't hear anything. So you and Sam are suffering from the same problem. Maybe double check on Discord. If you go under the gear icon at the bottom, you can select that, and then there's an option for voice and video where you sometimes can manually select input and output device. Discord sometimes is a little too smart for its own good for setting up its input and output. All right, next three, Ben, Fernberg, Josh, and Trent. Great, great, great. All right, next. I hear someone. Who's that? Great, gotcha. Is that a Discord settings? Okay. Dee Dee, Carson, and Taylor. Dee Dee, gotcha. Carson, gotcha. I don't see Taylor. Okay. If anyone is in contact with Taylor, could you reach out to him and just let him know that we are in Discord? There's a message in Slack, but I don't know if he's not tracking or is futilely trying to bash his way into Firestorm. Last three, Ethan Banez, Ben A, and Landon. Great. Who was the first person? Gotcha, Landon. And Nokless. Gotcha. All right, all right, so let me just review the people I don't have yet. Thomas, Taylor, and Ethan. Gotcha. Someone's was working now. Who was that? All right, I got Ethan and I got Thomas. All right. If anyone notices Taylor showing up, remind him to check in with me about attendance. Okay, great. All right, let me just word of prayer to guess what? Who was that? Taylor. Gotcha. All right, I'm just going to pray for a second. Dear Heavenly Father, wow, help us to be patient with the tools that you've given to us. Help us have grace for all the different crazy connections that we've got in the situation we find ourselves in. Also help us to be effective at learning things so that we can bring them to bear for your kingdom. Amen. Okay, great. A couple announcements. Let's start first of all with class on Wednesday. Class on Wednesday, our next class, today's Monday, so Wednesday the 24th, we're going to be doing something in person. The in-person nature of it, we're going to have a guest lecturer. And the guest lecturer is going to be Dr. Wonjun Lee. He is a professor from Yeshiva University, and he got his doctorate at Texas University in Austin, I think. Um, and he's going to be here doing a lecture, our first lecture on recursion, straight out of our textbook, so nothing not planned. He is interviewing for a position here at Westmont in the computer science department, so he's interviewing for an open position. So in addition to doing the lecture on Wednesday in our class, he will also be doing a research talk at another point. Possibly that information has gone out on email and I have not missed it, and I've missed it, but I'd encourage you to attend his research talk. He works in cybersecurity, and so his research talk will be about using metaphors and approaches inspired by biology to increase the security of containerized systems, if I understand correctly. So we're going to be in person on Wednesday. The question is, where will we be? What I'm going to say is we're going to be in the UN room in Winter Hall, which is Winter Hall 210. Now, that's a little funny because we're supposed to be online this week, coming back from spring break in order to just manage our COVID risk. Dr. Lee has been vaccinated. Dr. Howell's been vaccinated. I've gotten half of my vaccinations. I don't know how the class is doing, but there's enough space in that room that we're all going to be able to be 6 feet apart. We'll be masked. I'm not exactly sure if we're going to get permission to do that. And I know it's just 2 days away, However, it's the pandemic and everything changes at the last minute. So if we are not in 210, I will ask you to be resilient and be prepared to meet in a tent. I'm not sure which tent we're going to be in either, but that will be our backup plan. After Wednesday's lecture, we're going to return to our online um, lecture, and hopefully the virtual world will be up and running again. Um, and the plan is to continue online for the rest of the semester, although we'll play it by ear to see how that goes. Um, Not everyone can be on campus. Some of you are off campus and some of you are remote for a variety of reasons, not the least of which is health concerns. So I will be broadcasting the lecture in some manner using a YouTube link, like a YouTube live link. So I'll probably have my iPad there broadcasting live, like you might broadcast a live Instagram feed. Professor Lee's slides will be presented over PowerPoint. As a backup, we're going to do a web-based PowerPoint presentation. So if something goes wrong with the projector in the space, we're going to be broadcasting over a web interface. That's something that if I were teaching in person, I would do anyway, probably instead of the broadcast, so that you would watch it in a web browser. It's very difficult to get all this infrastructure up and running if you're a guest lecturer. So we're going to do our best, but we're going to accommodate remote students if you're not available to be present. I would love to have you present so that you can meet Dr. Lee and so we can get some feedback from y'all. But stay tuned for that detail. So again, Wednesday's lecture, our default plan is to meet in Winter Hall 210, which is the big high slope room. Looks like a law classroom maybe. And our backup will be a tent. And if that happens, we'll announce that on Discord. I'm on Slack, sorry. Any questions about that? All right, I bumped into Ethan this weekend or yesterday, I guess, walking the dog, and I couldn't recognize his forehead because he had his mask on. So this is a funny thing about this semester. We all know each other's avatars, and perhaps we know each other's masks. You guys probably know each other more from just being in closer proximity. All right, the second announcement is about the results of exam two. So exam two, I graded it over the weekend, and I was actually I was pretty pleased with the results. What I could say generally is that everyone passed, which is a great outcome. Um, the highest grade, so it was curved by 4 points. So everyone received 4 points in addition to the points that you got from getting the questions correct, which brought the top score up to 100%. The raw score was 77. So the high score was 77, and the average was 65 raw points, which was a B overall. That's a pretty good exam. Again, everyone passed. What I would really appreciate what I would appreciate from you all is if you could review your exam results and in particular review the grading. There was a couple things that Canvas didn't grade correctly by default, and I went back and I manually corrected it. Not the multiple choice, well, maybe the multiple choice. I didn't know that. If that happened in the multiple choice, I'm not aware of it. But in the short answers at the end, I had to manually go back and adjust a few things. So as you're going through your results, if you don't understand why you got something wrong, or I guess on the off chance you got something, I marked it right, but it was actually wrong, um, please touch base with me during office hours so that we can make sure that you got the correct grade and probably more important to me that you understand what happened in the error that you made. Some of you didn't ran out of time. That's a struggle with test taking. Some of you, in fact, I know would have done better if you had had twice as much time, but that's kind of the nature of tests, unfortunately. Um, any questions about the exam or any follow-up about that? Okay, hearing nothing, let's go ahead and try and shift gears into Eclipse. And this is going to be a little rocky given the way things are rolling so far. So what I'm going to do is I'm going to shift in the broadcast and in the screen sharing on Discord. I'm going to shift to Eclipse and I'm going to set up a project for us so that we can evaluate so that we can go through the building of a linked list. All right, there we go. There's Eclipse for you. Let me rearrange the window. Let me wait for my tools to catch up. There we go. All right. Okay, so today is class 27, so let me go ahead and get that project going here. And I am online in Saros, so I'm looking for all you folks showing up as well. Let's get that rolling. All right. See a lot of you, but the project's not being shared yet. All right. All right. Let me make sure that it's set up well so that it will run when you get it. I'm going under Java build path, and I'm making sure that our libraries are under the class path, not the module path. There we go. Okay, now I'm going to attempt to share it with you over Saros, so you should get your incoming request, your incoming, I don't know, alert here in a sec. Class 27, there we go. Wow, the gerbils are really working hard, but I had expected in this dialogue to see a bunch of people that are online, but I don't actually see people online. Is anyone online on Saros? All right, I don't see people online. That's troubling. Um, hmm. All right, okay, so let me talk it through. Uh, I've got Eclipse up and running. I have my project built. I'm looking at my Saros tab. My Saros tab indicates that I'm connected. I see also in my icon here that it's got a connected tab. But when I look down at my contacts and I expand it, while I see everyone in the class, I don't actually see the fact that you all are connected. So that indicates to me that Eclipse, the state that Eclipse thinks it's in, is not in alignment with the network. So I'm going to restart Eclipse and try and get it to be convinced that it's actually connected. Today's theme is reboot. If you're connected, I wouldn't. If you're connected and you can see other people are connected as well, I wouldn't restart Eclipse yet. All right, here comes Eclipse. Yeah, I think that the connection problem is just me. It's a me issue. All right, so let's see. Is my project still there? My project is still there. Good. Am I connected? I am not connected. Now I'm going to connect. Oh, I guess there's a small chance. No, you guys were there. I connected to the right server. We have a server on campus as well that you can connect to for Saros. But people that are off campus wouldn't be able to get to it. So I thought for a second that perhaps I was connected there. But nope, I wouldn't have seen you all as contacts if I was connected there. So I went ahead and initiated my connection, and it is taking a second for that to come together. I'm cracking my knuckles out of anxiety. I'm drinking coffee. My coffee is quite good. Hey, This is a good opportunity to do a Dodger report since I'm not connected yet and nothing can happen. And we're not going to be able to do a Dodger report on Wednesday, which will be a new chapter. So let's do a Dodger report. Ta-da. All right, so first of all, I'm still doing my pandemic bread. So this is bread from the communion on this Sunday. Came out pretty good. I take all my pictures and then I pick which one I'm going to put on Instagram. That's the one that made it to Instagram. I actually do communion for reasons other than posting pictures on Instagram, but that's a side effect. Here's Dodger this weekend. We had lunch out on the back porch. It was very nice. He was sleepy and enjoyed the sun. He goes hard and uses concrete as a pillow. That's just how he rolls. He's kind of a street dog. Later on, he woke up, but he was a little bit hot. There he is. That's my office. Okay. Great. All right. Looks like that was perfect. So now I'm connected and I see that you all are here as well. So I will now share the project with you. There you all are. Great. Here come the connections. And we'll watch that progress show up. Oop. Can you describe what you mean when you say it's messed up? Hmm. Well, that's on brand. All right, let me shut down a few more things in case it's a resource issue. And what I'll do is I'll restart my screen share on Discord. All right, so I'm going to stop my screen share and I'm going to restart it, see if that matters. Here we go. Sharing screen, screen one, there we go. And as long as, I'm going to turn off my video just because who knows what's going on. All right, does that look cleaner? Okay, great. All right. All right, Thomas, try restarting and restarting Eclipse, and then I'll reshare with you. Ben Fernberg, same thing. All right, and while the last few people are trying to connect, let's see, Ethan Vaughn, same thing. Now, some of you all, this may not be your problem, but it may be an issue with my firewall being slow to connect, but we'll do one more round. All right, Addie, I'm moving you to read only. Ben A, I'm moving you to read only. Carson, I'm moving you to read only. Faith, I'm moving you to read only. Wait for that to catch up. Okay, that didn't work. We'll come back. Josh, moving you to read only. Landon, moving you to read only. Monty, moving you to read only. Dee Dee, read only. Morgan, read only. Trent, read only. And then hopefully the folks who didn't connect the first round, you had a chance to restart Eclipse. Frank, looks like you too. And let's reconnect. All right, Ben Fernberg, try again. Ethan Vaughn, try again. Matthew, try again. Sam, try again. Thomas, try again. Boom. All right, Ethan, looks like, Ethan, Vaughn, were you able to restart Eclipse between those two attempts? All right, I'm not sure why that didn't take. Thomas, shifting you to read only. Ben, something went up with your sharing too. Okay. For those who failed to connect, please restart Eclipse before we do it one more round. All right, Faith will try and make you read only again, see if that works. Okay. What? All right, let's just give this a chance to settle out. Let's talk about what we're going to do here for a sec. So I'm sharing a little whiteboard here so that I can draw if everything goes well. I'm not great at drawing on digital surfaces, but we'll see how this goes. If you recall, we were implementing a linked list, and we were doing it in two different, or we are implementing a list data structure, and we were building it on different kinds of technologies. And the first kind that we built was an array list. And the trick with the array list was that we were keeping an array underneath the hood of our object that we were automatically managing for the user. And so within our class, that's not the kind of pen I want. Let's see, can I get a little bit sharper, please? Oh, the tools, oh, the tools. Okay, all right, we're gonna go with fuzzy. Okay, we're not gonna go with blue. Wow, sometimes you gotta laugh. All right, so under the covers, under the hood of our object, we had an array, and I'm trying to draw this array here with various luck. And each one of these components in our array had a reference to an object. And these were all inside a bigger object that was trying to abstract away the idea that the way that we were keeping track of a list was by having an internal array that we were managing the size of using a capacity indicator and using sometimes copying this array over to another array if we needed to. So this outer object was our array list. We'll just put an AL there to remind ourselves what it is. And when a user of our array list wanted to add something, we would accept that through like an add method, and we would place the object that the user wanted to store as a reference from our array list internally. They would add something else, and we would put something else in there. They would add three things, and we would put three things in there. And if they asked for position 1, we would look at our array and we would look up, if they asked for index 0, we would look at index 0 and we would return whatever was here without the user knowing that what we were doing was keeping track of our array list. If at some point the user filled up the existing capacity that we had here and ended up putting everything, all filled up the array that we had, and then went and tried to put something new in the array, we would have recognized that our capacity was already maxed out. And in order to be able to handle this new object that the user of our class wanted to add, we had to grow our array. And so we would make a copy of that array. It would have not the same length, but it would be double the length. And that extra doubling of the length was to give us capacity to add new things as the user wanted to add new things to our array. When we doubled our array list, we had to make sure that the objects that were there previously were still there, and we did that with a copy maneuver. And once we were done with that copy, we now had additional space for the user to add new elements, all the while not realizing that what we were doing was keeping track of things with an array list. And then we got rid of this old one, but we kept the data that the user was using along the way. What we want to do now is we want to do this as an array list. And let me give one more attempt at trying to fix my brush. Let's see. Here is a brush. Is there any way that I can get a brush dialog to come up? Here it says brush palette and brush library. There we go, great. And I want it not to be fuzzy. Can you make it not fuzzy for me, computer? Yeah, it's no better. Where would the fuzzy be? Saturation, all right, here we go. Luminance, nope. Size, opacity. Okay. All right, so we're going to try and build a linked list out. And a linked list is going to do the same work that our array list did, but internally it's going to keep track of a different kind of data structure in order to make sure that we're able to present this illusion of an infinite list that the user would like to have. And what we're going to do is, rather than keeping track of things as an array, we're going to have these things that are called nodes internally. And each node is going to be allocated separately, and they'll come from different chunks of memory. And each node will have access to the data that the user is putting inside of it here. And as the user adds new data, we are going to add new nodes to a chain of nodes. Now, these nodes aren't connected at all as I've drawn them right now. We would like them to be connected because one of the things about a list is it keeps track of the order. So in addition to having a reference to the data that we're keeping track of, we're also going to have a reference to the next object in our chain. This is what makes it linked. And if we have one reference like this is called a forward linked or a singly linked list. There's a single link, but we can also add another link so that we can go backwards in the chain, so that we can walk forward or we can walk backwards. Now this is a little bit tricky to understand, and so let's do some code to try and understand how this all comes together. So that's null. Just kind of important for, like, I'm a visual learner, so having these sort of visual diagrams of what's happening helps me to understand what I'm expecting in the code. So let's see if we can pull that out in the code. Oh, I think I know why it's fuzzy now. I think we're too zoomed in. It's too zoomed in. All right, so what I'm going to do is, just like we created an array list test, I'm going to try and create a new class, which is going to be the DP linked list. Let's go ahead and just, I don't think it's going to have a main. All right. And just like our array list implemented an interface called DP list, we're going to have our linked list do the same thing. Let's take a look at what we mean when we say implement the interface of the DP list. If you'll recall, the DP list has all these different methods: get first, get last, remove last, add last, size, get iterator, all the different things that you would expect a list to have regardless of its implementation. In order to be able to manage that structure, that linked list structure, we need to have some capacity to keep track of nodes. And so we're going to introduce the inner class. The inner class is a nested class, and it is helpful if you want a class that's only used within the context of the particular object that you're working with. So let's declare, just like we would declare an instance variable, or like we would declare a method, we're going to declare another class within a class that can only be used by DP linked list and can only be used internally if we make it private. And so we're going to make it private. This node is going to be the source of our chain, and this is the recipe. It's not an instantiation. So in each one of the stamped out versions of our node, what we want to have is we want to have the data itself, and so that will be a reference called data. And we're also going to want a reference to the next node in the chain. And so we're going to do a little move here that can be confusing the first time you see it. We're going to introduce kind of a recursive reference to a node. What you see here is you see a representation of a node that's referencing the same class in which it's defined. When you see it defined like this, that can be pretty confusing. But if you remember back when we had our diagram here, this isn't so bad because this is just indicating that we have one particular node right here, and it's pointing to another different node. So when you actually instantiate it, it's not quite as confusing as when you define it and it looks recursive. We'll start out with a singly linked list here. All right, so to this, let's start a constructor. Let's create our constructor. And in the process of making our constructor, we will be able to see what other instance variables we need. So our constructor, when someone wants to use our linked list, we'll call the DP linked list constructor. I'm going to sneeze, excuse me. Give me a sec. I'm going to sneeze. Excuse me. All right. And what we're going to do when we first make our linked list is we need to start that chain. And that internal chain will be launched with an instance variable that's present. It will be a reference to the first element in our chain. Again, you can see that this is an instance variable. It is a reference. It is a reference to something that is of the node class. When we use it as an instance variable, we haven't initialized it. When we call our constructor, like a best known practice, we're going to go ahead and initialize it. And we're going to initialize it to null because when we start our linked list, there's no data in it. And it's just a list with size 0. All right, so then the next thing that we're going to do is we're going to imagine that this is actually filled out. That in a future call, first doesn't equal null. We don't have the capability to do this yet, but we're going to go ahead and pretend as if we did have a chain here, and then we'll go back and fill in the difference. So let's go to our implementation and see what our interface is. Looks like get first. All right, so I'm going to copy that and go back to linked list. And I'm going to add a get first method. And that's part of our interface. I'm now going to implement it. And it is going to be public. And I will go ahead and use the tag override to indicate that I am overriding my interface. All right, I haven't actually done anything, but what you can see is this is a method that returns our first data. Now, it's not going to return the node, but it's going to return the data that's present in the node. So what we'll do is we'll ask, well, let's see, is there data in our chain? Well, if there isn't data in our chain, then first will be equal to null. And what we're going to do is we'll throw a no such element exception. This is as if you've asked for the first element in a linked list that has 0 elements in it. And we'll need to import that. All right, on the other hand, if there is data in our chain, then it's straightforward enough. What we want to do is return. Now you might be inclined to say, I want to return first. And that seems like it might be the right thing to do because the method is called get first. But remember, from the perspective of someone who's using our linked list, they don't know about the node class. And so if we return first, what we're returning is a reference to the node, to a node. They don't know that. We don't want them to know about that. So instead, what we're going to do is we're going to reach into the first node in our chain, and we're going to return the data that's stored there, not the node itself. Now, from the perspective of the user, that's exactly what they want. They want the data. They don't want to know about all the information that we're storing along the way. All right, so now let's go ahead and add something to our chain. And let's go ahead and create something called add first, sort of a similar method. Add first should take in the data that it wants to store. And it doesn't actually have to return anything because it's just changing the chain. All right, so this means that we possibly have a chain already. Maybe first is null, maybe first isn't null. And what we want to do is we want to create a new chunk of memory and we want to add it to the beginning of this chain. So first, let's make that new chunk of memory. That new chunk of memory will be a local variable. We'll call it new. I don't want to call it new node. We'll call it a link for link in the chain. And we'll say that that's going to equal a new node. All right, so we just called the constructor on our node class. We did not explicitly write a constructor for our node class. We could have. We could have put something in here that just said public node. We could do that. Just like any class, we could write a constructor for it. But we're happy to take the default constructor which takes no parameters and sets all of its instance variables to null. That's what the default constructor does. Or if it's like an integer, it'll set it equal to 0, or a double, it'll be 0.0. By default, the default constructor just kind of initializes all the instance variables. That's fine. So we're going to get this chunk of memory, and now we want to take the data that the user has presented to our linked list, and we want to store it in that link, in that new chain. So we're going to say link.data equals data. Data here ends up being stored here, and link.data is the data node in our chain that we just made. So just like in getFirst, when we return first.data, in addFirst, we're going to put it here in the data field of a node. So that's fine. Now we need to link in this chain. We need to link in this node to the existing chain. So the first thing that we want to do is we want to make sure that this node, so link.next, points to the existing first element. So that's good. That puts this link at the beginning of the existing chain. And now we want to update the knowledge of our chain, the knowledge of what our linked list is, so that the first element is no longer the second element, but it's actually the first element. So this is how we repair the chain. And let's see if we can draw what that looks like here on the scrapboard. So when we create the new element within our class, this should be happening within this box, but we'll create our new element here. That's a new node. We then take the data that the user has added and we put a reference to it. We then say, okay, this link has to point to the first element here. And then the instance variable first, which previously was pointing here, we now have point to this. So as we walk down the chain, we go from first to this node here, then we go to the next element, and we end up here, and here, and here. And so in this diagram, we have 4 different nodes. Now notice that this add first is going to work whether first is null or whether first has a data chain. Because if first is null, then link.next will be assigned null. And that's great because that means that our first link in our chain points to null as the next element. And so the first link in our chain is also the last link in our chain. And on line 33, when we repair the beginning of our list to point to the beginning of the linked list, everything is cleaned up. All right, so let me stop there and see if anyone has any questions about that much. Okay. Let's do the reverse now. Let's go ahead and implement removing the first node. This is similar because it has to make sure, it kind of does it in reverse, but what we have to make sure that we do is we have to make sure that we repair the node. So we're going to remove the first element. That doesn't take any input parameters, and as a side effect, we'll go ahead and return the data that we removed. And this will be removed first. Okay, so how are we going to do this? Well, first of all, we want to check to see if there's actually data in our linked list, because one of the corner cases is that there's no data. All right, so if there is no chain from which to remove our first element, we'll go ahead and throw a no such element exception. Copy that code from up there. All right, if we get past that and we don't throw an exception, then we do have a chain, and we want to save the data that is on our first node. So the return data, we'll call it ret, equals the data that is stored at our first node. Okay, so we're going to keep track of it, and that's important because we're about to lose our first node as we splice it out. So now what we're going to do is we're going to say that whereas before we were pointing to the beginning of our chain with first, Now what we're going to say our first element points to is whatever our first node pointed to afterwards. So it's going to point to our second node now. That's all we have to do, except that we have to return the data that we pulled off now. All right, and so visually what we just did, let me draw a new chain here. We had a linked list where our first element, get a little laggy on my drawing, so things are a little funky, sorry. Here's an example of nodes that are in our linked list. The first element currently points to this node. Each one of them have data stored at them. And each one points to the next element in the chain with the next variable. So in that code, what we did is we said, okay, let's save first.data, that's this, to return. Now let's say first no longer points to what it did before, but instead first points to whatever first.next points to, which is right here. And so we say, okay, now it's going to point here. That leaves this node out to dry. It is no longer referenced by anything. It does have a reference out, but no one is referencing it because first no longer points to it. It points here, and there's no way to get this link back. And so this gets garbage collected and gets reused by the system. Our chain is now 3 links long instead of being 4 links long. All right, questions about that one? All right, now let's talk about how we might implement an iterator in this particular class. So our iterator, we have an interface for our iterator as well. And our iterator has things like has next and after. But what we know an iterator has to do is it has to act like a cursor that's walking down our linked list. So this is going to be a little bit sophisticated, but we're going to do the same kind of a similar thing that we did before. We're going to create a class that we can use internally to represent our iterator. All right, so we're going to have a private class called linked list iterator, and it is going to implement dp list iterator. So this is another helper class that's internally helpful for us. All right, we'll leave that unimplemented for a second. And what we'll do is we'll add down here the method from our list interface. Trying to open that file. Come on now. There we go. Which is get iterator. So I want to implement that. And we're going to return something that implements dp list iterator. And it's going to be called get iterator. And we're going to implement it. And when a user of our linked list asks for an iterator, we're simply going to make one of the iterators that we have internally and return it. Now it doesn't do anything yet, but that's how we're going to make it work. All right, and what's the problem? Change visibility public. Great. Okay. All right, and actually we're overriding our interface, so I'll go ahead and put that in there as well. All right, so now we need to do a little bit of work to make our linked list do what we said it needs to do. Go ahead and ask Eclipse to stub out all the methods that are necessary for this interface. For example, has next, next, remove, set, all these things. And then we're going to create our constructor, and we're going to create some instance variables. So this is something that needs to walk down our chain. And so our instance variables for our iterator are going to be a node in the chain, which is the current position. And we're also going to have a node in our chain, which is the previous position, because this is like a cursor. So we need to sort of have the two sides on which our cursor exists. We're going to keep track of true or false, whether we just whether someone just executed a next step. That's so that we can remove things effectively. And then let's create our constructor that will initialize everything. We'll start with position equal to null. We'll start with previous equal to null. And we'll start with is after next. After next equal to false. So our iterator starts without much information. All right. So to step over our next element, let's see. Let's start with asking whether there is a next element or not. So let's imagine that position and previous are all correctly set. We're in the middle of a chain. And what we're going to do is we're going to say if our current position is null, sort of at the case where we haven't started our cursor yet, then we're going to just see whether or not there's one element in our list. And if there's one element in our list, then there is an element if first is not equal to null. So if position equals null, that means there's one element in our list, our cursor hasn't started walking yet, and whether or not there's a next element is exactly whether there's any element. Otherwise, we're going to check to see whether there's something to step over on our position node. So if position.next is not equal to null, meaning if there is something else to look at on our chain, then we will return true. And that gives us two return statements and we're all set. Now when we actually want to do the next, so when someone calls our next and wants our iterator to step over an element, what we'll first do is we'll say, hey, if you say, we'll call our own method if has next, and if it's false, so if you just say next, if you ask me to go to the next element and there is nothing to go to next, then I'm going to do my trick of throwing a no such element exception. Previous will equal our current position. So we'll step forward in our chain. We'll set is after next equal to true because we just stepped over something. And then we'll say if position equals null, then we're at the beginning of our chain and the first element that we're stepping over is our first element. Otherwise, we're going to walk down our chain by one. And then the last thing we need to do is return the data that we just stepped over. And we need to import that. What did I do wrong? No such element, throw new. No such element exception. There we go. Okay. Good start of building our linked list. I'm noticing the clock, and because we had a difficult start, we were not able to get as far as I would like. I think it's very important that we get to the point where we can compare the performance of array list and linked list. I think that's a very important thing to understand. And so I think what we're going to do is we're going to return to this implementation on Friday. And so we're going to have a little bit of a complicated intellectual task for you, which is on Wednesday, we're going to start introducing the idea of recursion. And we need to keep that steady because we have our guest lecturer. And then on Friday, we'll come back to this to finish talking about the difference between how a linked list and an array list performs. And then on the following Monday, we'll continue our discussion of recursion. So just, oh well, that's sometimes we got to call an audible and do something a little bit different. I'll try and get our virtual world working so that Friday we can join again in the virtual world. Otherwise, stay tuned for where we're going to be on Wednesday. As a reminder, Wednesday we're going to be in person, probably in room 210, Winter Hall, which is the UN room. That's all we got for today. I'm happy to take any questions that you have, and I'll stick around for a sec. Thank you. Welcome. Take care. Yeah. hmm hmm Yeah. Are you still on Saros? Oh, you never got in. Okay. Yeah. So, well, I I'm broadcasting on Discord. What I'm broadcasting in Discord shows the way in which you would change this. So right now, what we're doing is we're walking through a singly linked list where a node only points to the next node, but you could make this a doubly linked list by having a node also point to the previous, like that. And the reason why you want to do that is because it makes some operations faster. So operations that require you to be able to get to the previous element, in particular, if you want to remove something, you need to patch up the chain. In order to patch up the chain, you have to step back and then make the link jump over the element that you're removing. And so that ability to just step back really quickly really improves the efficiency of a linked list. It's a little bit of an administrative headache because you have to be constantly worrying about whether your next and your previous links are correctly assigned as you do all your different operators. But it's worth it because the implementation matters or the efficiency changes so much. Well, that's interesting. The idea of a triply linked list doesn't make a lot of sense because a linked list is linear. And so you only have forward and backward chains. But if you want to abstractly think about multiple connections besides just previous and next, now you're starting to talk about a tree. And so a tree is kind of like a triply linked list where you might have a node and it has a parent and two children. That would be a binary tree. And so every particular node in the chain could split into two chains, not totally like a blockchain. Um, and so that would be an example of a triply linked list. But generally speaking, any one of these nodes doesn't have to just connect to one next node or two next nodes. It can connect to as many next nodes as you want, in which case you're talking about a data structure called a graph, graph. And a graph is like when you have, it's like cities on a map that are connected by roads. Each particular city might have many roads going out of it to connect to another city, and that would be like a single node that we've been looking at today connecting to many different nodes. So what we do is we introduce these in sequence. We talk about a singly linked list, then a doubly linked list, then a tree, then a binary tree, then a tree, then a graph. Great. Thanks, Ethan. Yeah. When you do coverage, that's okay. That's not indicating that something has gone wrong. What that's saying is that only one only one situation is being run. So when you have a branch, so like usually you're used to seeing it be red, meaning the line of code didn't get run, or green, the line of code did get run. When it's yellow, it means that something about that line of code is conditional, and it means that one half of it ran. So if you have assert true, what that means is that you're only running it in the true case, or maybe only running it in the false case, but not both the true and the false case. But regardless of that, the code coverage in your JUnit test doesn't matter quite so much because your goal isn't to get code coverage in your JUnit test. Your goal is to get coverage in your class that you are evaluating, if that makes sense. Like you want the code coverage of the class that's being tested to be green. That would be the ideal, 100% green. But the JUnit test, you don't care if that's all green. I mean, it doesn't make sense to have code that you're not running, but like that's not the JUnit test is a tool in order to get code coverage complete on the class that you're testing. It happens to be that code coverage also records the coverage of your JUnit test, but that isn't something that you should be focused on. Yep. Hi, Matthew. Oh yeah. All right, so let's see. Let me on Soros. I see that you're still there, and let me see if we get a good connection. Are you getting a request? Okay. All right, it should have connected by now, and since it didn't, something has gone wrong. So what I'm going to do is I'm going to stop sharing this session for a moment. Let's see, stop sharing, and I'm going to just share it with you. I think I know what went wrong, and I think it's probably my fault actually. Oh yeah, that'd be good. Okay, you should have gotten another request to connect. Did that come through? Yeah, and on mine it says that I'm inviting you and waiting to connect. All right, where are you located physically, Matthew? Okay. Where does your VPN connect to? Uh, it looks like it just came through. Did it work? Your hang on one sec. I got it. Someone at my door. Yeah. Um. Okay. So that was the first one that shared. Okay, an oscillating P2P. Oh, sorry. Oh yeah. Hmm. That's interesting. Okay, and what else did you need? Class 25. All right. Let me share that, and then I got to run because I got a meeting I'm supposed to be at. All right. Yeah. Wait. You got one more. Here we go. All right. Did you get a request? Oh, there it goes. Looks like it's okay. Great. That looks like it worked all right. Okay, thanks, Matthew. Take care. Bye. Wow, and so now I can see that that entire class. I was recording the title screen. All right, that's too bad. Okay, we'll try again next week.